Hello guys, I am Srinath from Kappagam College of Engineering. I am studying third year in Electronics and Communication Engineering. I did internship at IoT in Emertxe Information Technologies. In this video we are going to see about the internship project and what I had learned in this internship. Let's get into a video. At first we learned about the C programming fundamentals. In C there are data types. They are character, int, float and double. Character holds character values and the integer holds integers. Float holds decimal values and double will holds large numbers, integers values. And operators, there are arithmetic operators which includes plus, minus, multiplication, division and modulus, and bitwise operators and logical operators, and then conditional statements which are if else and switch cases. In loops, for loop, while loop and do while. In for loop the condition will be checked and then it will enter into the statement. In while the condition will be checked and then it will enter into the statement. And in do while the statement will be executed and then the condition will be checked. If the condition is correct, then output will be displayed or the output will be not displayed. And then arrays will store the sequence of elements. And then string functions. Pointers is nothing but which we can get the values by passing the value address. There are two types of pointers, pass by reference and pass by values. And then functions and recursions. Recursion is nothing but the function will be called by itself. It is called recursions. And the memory segments, there are text, data, stack and heap. And then in structures we learn about the introduction to C++ and OOPS concepts. And then embedded systems. Embedded system is a combination of hardware and software systems which is intended to do a specific task called an embedded systems. In embedded system we can perform a specific particular task which we assigned to that electronic devices, or which we program the electronic devices to do a specific task. It has three parts. They are software, firmware and hardware. Embedded systems have peripherals such as serial communication interfaces, synchronous serial communication interface, universal serial bus and multimedia cards, etc. And classifications of embedded systems. Real-time embedded systems, strictly time specific, which means these embedded systems provides output in a particular or defined time interval. These are the real-time embedded systems where we can get the output immediately. Example, traffic lights. These type of embedded systems provide quick response in critical situations, which gives most priority to time-based task performance and generation of output. That's why real-time embedded systems are used in defense sector, medical and healthcare sector and some other industrial applications where output in the right time is given more importance. Examples, traffic light control systems. Another embedded systems are standalone embedded systems, mobile embedded systems and network embedded systems. Standalone embedded system are the embedded systems which can operate on themselves. They do not depend on any other medium. It is an independent systems which can work by themselves. They don't depend on a host. It takes input in digital or analog form and provides the output. Examples of standalone embedded systems are MP3 players, microwave ovens and calculators. Mobile embedded systems are portable and movable embedded systems. Examples are smartwatches, mobile phones. And network embedded systems, here where embedded systems, the electronic devices are connected with the network and do some specific operations. They are connected to a network which may be wired or wireless to provide output to the attached device. They communicate with embedded web server through network. Examples of the network embedded system are ATM machines, home security systems. Other terminologies of these embedded systems are microprocessor and microcontrollers. Microprocessor is a bare processing unit with input-output, RAM, ROM, and other peripherals connected externally, and microcontrollers are processing unit of the computer, input-output ports, RAM, ROM, timers, etc., and it is integrated on a single IC. They have ADC block and DAC block, timers and counters, pulse width modulations, processor, memory and input-output ports. System on a chip. Multiple microcontrollers and microprocessors integrated on a single IC, along with additional features like digital signal processing unit, radio signal processing unit, and Wi-Fi modules, etc. Memory and types. There are two types of memory, RAM and ROM. RAM is a random access memory and ROM is a read-only memory. In RAM, random access memory is a volatile memory which requires power supply to retain data. It can be written over multiple times. Types of RAM are static RAM and dynamic RAM. Read-only memory is ROM. It is non-volatile. Data is not erased when the power is shut down. It cannot be changed once written. And types of ROM. Types of ROM is one-time programmable, OTP, EEPROM and UV-ROM, masked ROM. Hybrid memory. It is non-volatile but can be changed or overwritten for a particular number of times. And types of hybrid memory are EEPROM, flash and NAND. And Internet of Things. What is Internet of Things? Internet of Things is a network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. In simple words, Internet of Things is a connection of electronic devices or components with the internet to do a specific function. These devices ranges from ordinary household objects to sophisticated industrial tools. And the collective network of connected devices, technologies that facilitate communication between devices over the internet. IoT system works through the real-time collection and exchange of data. And the applications of IoT are automobile, manufacturing, logistics and transport, and it also used in the business. And examples of Internet of Things are wearable health monitors, smart cars, smart buildings, and home automations. And we will see about the overview of the project. The project is based on the home automation solutions. The solution is given by the Internet of Things using Arduino Uno board in Pixim's Lab Simulator. Blink IoT mobile application is used to control the devices remotely, control the lights, temperature of the home, and inflow and outflow of water in the water tank. This is the overview of the project. The objective of the projects are it connect the home appliances to the Arduino and integrated it with Blink IoT app with Blink Cloud, and the project is about the controlling of lights, temperature of the home along with the level of water tank using mobile app. We can use this project application in the real time, but in this project we will see about the software simulations. Why we should use home automation? Generally, people always don't stay at home. This brings the problem of home appliances not being monitored. The solution for this problem comes out to be home automation. Home automation enables people to control most of the devices remotely. Volume of water present in the water tank, garden lights, temperature of home can be controlled using the home automation project. And Arduino. Arduino is a microcontroller board based on Atmega 328P. It has 14 digital input-output pins, 6 can be used at pulse width modulation outputs, 6 analog input-output pins, and it can be programmed using different IDEs. Arduino IDE integrated development environment is used in this project. Arduino IDE supports C and C++ languages. And PixSimLab. It is a emulator where we can use the Arduino board as a software tool. PixSimLab is an open source real-time emulator of development boards with integrated MPLABX or AVR GDB debugger. It supports some PixSim microcontrollers and some SimAVR microcontrollers. It has integration with Arduino IDE for programming the board's microcontroller. And we will see about the Blink IoT configuration. In this configuration we will see how to create new template, how to add device, how to select and add data stream, how to create icon, how to include Blink library. And the components used in this project are LDR sensor. LDR sensor is a light detecting sensor that detects the light that falls upon it. The photoresistor is a light controlled variable resistor. The resistance of a photoresistor decreases with increasing incident light intensity. The LED lights are connected to the LDR via analog to digital converter. The analog to digital converter converts the analog input by the LDR into its equivalent digital form, which is then converted later by certain formula from 0 to 255 as upper bound. Based on this, the LED will glow. And the next component used in this project is temperature sensor. The temperature is recorded using LM35 sensor, which reads analog value. The value is converted into binary value and later actual temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibration or trimming to provide accuracies of 0.5 degrees Celsius to room temperature and 1 degree Celsius over the minus 50 degrees Celsius to 155 degrees Celsius temperature range. And the control system of temperature consists of heating resistor and LM35 temperature sensor and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and displayed on a CLCD after converting it into digital value by using ADC. The control of temperature of system by turning on or off the heater and cooler through Blink IoT mobile app. And the next component our intention to do is to control the water tank inlet and output valve control. The volume of water in the tank through serial communication display it on the CLCD. The control of the volume of water in the tank by controlling the inlet and outlet law by sending commands through serial communication and display the volume of water in the tank on the CLCD and also in the Blink IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liters and it stops filling when the tank is full at 3000 liters. Gives notification to the Blink IoT app. And this is a software simulation which the LCD will display temperature, water, liter and inlet outlet valve control on or off. And the conclusion of the project is we did the internship with the project of IoT, which is based on the home automation, which will controls temperature, garden lights and the water tank in real time. In this project we did all those with the PixSimLab simulator, which is an emulator. We can do this in the real time or in the software simulation we can do this kind of projects. And we will see about the project in the Arduino IDE and the PixSim emulator lab with the Blink IoT and to control those projects.
Which we have used in our project. This part is for IoT app, IoT Blink IoT authentication, which helps us in monitoring our code from mobile. The first part in our code is for uh, temperature system that is given here, and When the temperature is greater than 35 degrees Celsius, that is here, the heater should turn off because that is not a normal for a room temperature. And when temperature is less than 28 degrees Celsius, that is the actual room temperature that is shown here. The cooler should turn off here. That is the second part of our project, temperature system. And third last part of our project is about cereal tank. When the tank volume is less than 1500 degrees Celsius, that is what we have taken in our project. And when less than 1000 degrees Celsius, the inlet should automatically turn on. Uh, and a notification should pop up saying that inlet valve is the water level is less than 1500 liter, so inlet valve is turning on. The maximum level is here 3000 degrees Celsius, 3000 liters, and when tank reaches the 3000 liter, the inlet valve should turn off. And whenever we turn on the outlet valve, the water should flow in opposite direction. Okay, first part of our project is about garden lighting. This is the LDR. When resistance of LDR is very high, garden light should turn on. That means it is night time and LEDs will glow. Uh, Next, when we decrease the resistance of LDR, the light should slowly turn off. As we can see, now the light is turning off and it is completely off now. This indicates that it is daytime and LEDs will turn off. Next part of our project is about temperature in a home. And as we can see, this is our Blink IoT app, which we are monitoring with our mobile. And when I turn on heater, the temperature should go till 35 degrees Celsius. When temperature is greater than 35 degrees Celsius, that heater too should turn off, and we should get a notification in our mobile screen saying that the temperature is greater than 35 degrees Celsius, and heater will turn off automatically. Now, if I turn on the heater, yeah, as we can see, the temperature is increasing slowly, and when temperature is greater than 35, it should turn off. Yeah, now we can see that the temperature has turned off. uh, and a notification is appeared here saying temperature is greater than 35 degrees Celsius and heater is turning off. Now, if I talk about cooler, when I press this cooler button, temperature should fan is rotating now, as we can see, and temperature is decreasing. The cutoff for temperature is 27.9 degree Celsius. At that time, at that point of uh, at that temperature, the cooler should turn off and notification should appear here. As we can see, notification also appeared here saying that the cooler has turned off because it is a normal room temperature. This is about our temperature sensor project. That is the second part of our project. The last part of our project is uh, about a cereal tank, and in the cereal tank, the maximum volume of water which it can store is 3000 liters. And now, initially, I have completely filled the tank. That means it is completely filled, and 3000 liters are filled here. Inlet is currently off as it is completely filled. Whenever I uh, turn on this outlet, the water should flow in opposite direction. That means it should empty the tank. If I turn on this, uh, yeah, as we can see, the water is decreasing. The cutoff what we have taken in this is 1500 actually. That is what we have made changes in our code. Uh, uh, and whenever it reaches below 1500, yeah, it reaches below 1500, the inlet should turn on. As we can see, the inlet is turned on now, and a notification has popped up here saying that water level is less than 1500 and inlet has turned on. Uh, Now I cannot turn off the inlet now because it has already reached the cutoff. Now if I turn off the outlet, it should increase again. As you can see, the water is increasing here, and notification will pop up here saying that the water is completely filled. Uh, Now if you see here, yeah, now notification has popped up here saying that enabled water level is 3000 liter water inflow disabled. Inflow is now disabled. Inflow will disable only when the water is completely filled or it is greater than cutoff. But below cutoff, we cannot turn off the inlet. And now again, if we can turn on the outlet and we can see that water is flowing in other direction. And I can turn off the outlet now. Yeah, as we can see, inlet has not turned on now because the cutoff has not reached yet. And water level is, and we can see here water level is 2250. And that is about our project. Thank you.